Welcome to Maths for You channel. A past question on coordinate geometry. Let C be the parabola parametrically given. Parabola equation is parametrically given by x equal 80 squared and y equal 280 for t is an element of real numbers where a not equal 0, we'll talk about it later. Show that the equation of the normal line to the parabola C at the point 80 squared 280 is given by y plus tx equal 280 plus 8t cube. Okay, let's start with the question. Is always the sketch. I just put a little sketch. Always sketch is a lot better to especially doing this coordinate geometry. So coordinate geometry, the sketch is important. So XY axis, and I put parabola. Before it's been given parabola, but is it symmetrical about x-axis or whatever is up parabola, down parabola, or the symmetrical about the x-axis? We don't know. We only know the parabola, but let's give you the little clue. We know that parametric equation x equal 80 squared, y equal 280. If I could actually square y, is y squared equal 480 t squared, because of x is already has t, so it's just trying to get t squared to y as well. So y squared equal 4a squared t. If you could substitute 80 squared with x, so x equal 80 squared, if you do that, that will be 80 squared is 4 x, and then left with 4, so 4ax, so y squared 4ax. This is definitely a parabola, but symmetrical by x-axis. It gives you more information. When you do that, this gives you more information. So it's symmetrical by x-axis, and it is going through 0, 0 origin. So that's why the sketch been done. After done this one, of course, you know, if you sort of familiar with this parametric equation, of course you can do this sketch prior to doing this, but I just give you the bit more info how we actually sort of find out the parabola is symmetrical by x-axis and going through 0, 0 by doing this replacement of a t. Okay, right, this is parabola. Then the question asks, show that the equation of the normal line to the parabola C at the point 80 squared 280 is given by such. So what they're saying, a normal to parabola, any point. But when you say a normal to a curve, that means it's normal to a tangent to the curve. So here, normal to the tangent to parabola. So prior to going to normal, let's deal with the tangent. So gradient of a tangent to parabola or any curve is always given by dy over dx as a standard property, a differentiation property, a curve gradient property. So, we know x equal 80 squared, so dx over dt is 280, 2 times a t. And y equal 280, and dy over dt is 2a. What we need, dy over dx. So dy over dx equal dy over dt times dt over dx. The dt cancel, if you could imagine, the dy over dx. So dy over dt is 2a, and dt over dx is 1 over dx over dt is 1 over 280, and 2a cancel, 1 over t. So this is the gradient of the tangent to that parabola. What we need is the gradient to the normal. So gradient to the normal of tangent is minus t. I just put it straight, but we can explain that what it is. The gradient and the tangent are, the tangent and normal are perpendicular to each other. Therefore, the gradient of tangent, gradient of normal multiplied together is equal minus 1. So gradient of tangent is 1 over t times m2 equal minus 1. Therefore, m2 equal minus t. So the gradient of normal is minus t, which we have found. So we have found this the gradient, and we know the point where that normal going through. It's an arbitrary point, 80 squared to 80. Then we can find the equation. We know the coordinates of a point and the gradient. Therefore, the equation is y minus 280, the y coordinate, x minus 80 squared equal minus t. If you cross multiply that, y minus 80 is the left hand side, the right hand side minus time x, minus t times x is minus xt, plus minus minus plus 80 cubed. 80 squared times t is 80 cubed. We want to just tx, so xt, tx is same. Tx to the left hand side, y plus tx equal, and take that 280 to the other side, 280 plus 80 cubed. This is exactly the format we have been asked to prove. So that's been proven. So first part done. The second part, the normal line at a point P, anywhere point P, is the coordinate of point P is 4a, 4a. On the parabola C meets the parabola again. So when you actually extend that normal at P 4a, 4a, it will actually meet the parabola to the other side. At the point Q is actually meeting a Q. Coordinates of Q is a capital T squared 280. It's a small t equal capital T. Show that capital T equal minus 3. Right. Right, we have found the normal. It's this is a standard arbitrary equation. Any normal, any point on the parabola, normal to that point, equation of that normal to that point is y plus tx and all. So it varies with the value of t. Where the t changes, the equation is changed. But prior to do that, we know x at p, x equal 4a, y equal 2a. So if we could find the value of t, we found 2. How we found it is simply just y equal 4a, y equal 4a, y equal 2at. That's the parametric coordinate. So 4a equal 2at, 2a to cancel 2, t equal 2. So t equal 2. At p, t, value of t, small t, is 2. Right. So we know the equation of normal at p. We can find it because of the equation we already know, the standard equation. All we need to find the value of t, which we have found at p. So therefore, the normal equation will be ytx equal 2at plus at cubed. That is what we found is an arbitrary normal equation, any point on the parabola. Now we decided the point, which is where t is plus 2. So if you could substitute that value for 2, that's y plus 2x equal 2a times 2 plus a times 2 cubed. That is y plus 2x equal 4a plus 8a, that is 12a. So this is the equation of normal through point P. But that line is actually meets the parabola again at Q. The Q's coordinates is given at cubed 2at. So this coordinates Q is on that equation normal. Therefore, this coordinate should satisfy the equation. So all you have to do is just put this value to x and y. So y 2at, 2a capital T, plus x, 2 times x is a times capital T squared equal 12a. All the way you can take 2 out, 2, 2, and 12 divided by 2, 6. And a out, a, all out. So what we left is t squared plus 6. So this is a quadratic equation in terms of capital T. So we can rewrite this t squared plus t, and take the 6 to the left-hand side, minus 6 equal 0. We need to find the value of t. Therefore, this is a quadratic equation. We try to see whether we can get factorized. Yes, we can. Put a little cross. This is how I do it. T times t is t squared. And then 6 factors of 6 is 2, 3, minus 6. Therefore, minus 2, 3. So if you could do that, t times t is t squared, plus 3t. T times 3 is plus t. And minus 2 times t is minus 2t. Then add them together, you only got t. And then minus 2 times 3 is minus 6. So the factors are t minus 2, t plus 3. So from that, t equals 2 and t minus 3. But they ask us to prove t equal minus 3 at q. Because of t equals 2 is at p, because we proved it. Even though small t over t, the t is 2 at p. So that's not what we want. So the other value is the right one. Therefore, t equal minus 3 at q. Thank you. Please subscribe the channel. If you are watching, please subscribe and watch properly full video, and pass this contents to or share this contents to other students and friends. Thank you.